Hi, my name is Tony Morrow, and this is Introduction to Project Management. In the last episode, we planned the scope of the work to be done, and in today's episode, it's all about time and schedule management. Before we dive in, I want to preface this episode with a reminder that we are using the waterfall methodology as the basis for this course. In many projects, and in fact in life, we use a less prescriptive or cookie cutter way to schedule our activities. I get a call that my kids are sick and I need to pick them up from school, or you realize that it snowed last night so you might need some extra time on the commute to work. In iterative models like Agile, we evolve rolling schedules that deliver on features or elements of a project or product. Software developers use this to flesh out features, patches, or evolutions in software design in response to available technology or user preferences. How many versions of Windows or iOS have you used? Both of these can be responsive approaches to changes in the product lifecycle. But when I go to sleep, I have a plan for the next morning that takes into account coffee, exercise, travel time, and when I need to be where I need to be. This is the more predictive style we'll explain today. As part of this, and we've already started, we need to plan out our schedule management. Planning schedule management, as defined by the PMBOK, is the process of establishing policies, procedures, and documentation for planning, developing, managing, executing, and controlling the project schedule. We just started doing that here by prefacing our waterfall scheduling practices versus iterative or on-demand scheduling. As we did in scope, we need to plan how we are going about developing our project schedule and what tools and models we'll be using. In order to get started on this, we'll need our classic inputs again. We'll need our project charter, our scope management plan, which we just finished, and don't forget our Fs and OPAs. With these references in hand, we'll need to apply some expert judgment to the situation. These are team members with experience in scheduling a project like this or experienced practitioners in predictive or iterative life cycles. Perhaps they have experience with specific scheduling software or this industry in which the project is being delivered. Add to the expert judgment any data or analytics that can better inform the process. How detailed does the schedule have to be? How much work is involved to maintain the schedule? At this stage, holding meetings with stakeholders, the sponsor, the project team, and you, the project manager, will be important to understand the urgency of any timelines and to understand how flexible your schedule can or cannot be. When complete, your schedule management plan can provide you reporting formats, units of measurement, and levels of accuracy, or essentially the level of detail required. It can inform you on how much flexibility you have, or more formally known as control or variance thresholds. Essentially, how late or early something can be before action needs to be taken. Now that we have the framework of our schedule in mind, let's start the process of populating it. In order to do that, we'll need to identify and define the activities that make up the body of our schedule. The PMBOK defines defining activities as the process of identifying and documenting the specific actions to be performed to produce the product deliverable. In order to do this, we'll need our schedule management plan, that framework that we just completed, our scope baseline, which includes our WBS, WBS dictionary, and scope statement. And, of course, our Fs and OPAs. With our references in hand, we now apply some expert judgment, like we did moments ago. Using that expert judgment and meeting with your team, stakeholders, sponsor, and any other parties who can help, you start a similar process of what we did with the WBS, decomposition. In this case, we are creating outputs, where, as with the WBS, we were focused on deliverables. In making my morning coffee, I need to measure and fill my coffee grinder with beans. Then I grind them and output coffee grounds. I measure and fill my coffee machine with water and the coffee grounds. Then I brew the coffee. When done, I will output a pot of coffee. I will then select a coffee cup, fill it 3/4 full with coffee, and add almond milk or cold water. The output and my deliverable is now 1 cup of coffee. In this example, the grinding and brewing and the pouring of the coffee were all activities, but the final cup was the final product of that work. So, a cup of coffee is the output of the WBS. The grinding, the brewing, the pouring, all equal activities in my WBS, which we've defined and identified in defining activities. In this example, we now have a list of activities: the grinding, the brewing, and the pouring, which are all activities required for the project of getting my cup of coffee in the morning. In addition, I described each activity and the components of each. These might change in the future. Perhaps I add a mix of beans to the grind activity, or a pinch of salt in the brewing, or frothed almond milk, or some kind of latte art. These would all be changes on how the activities are executed, but not fundamentally change the activity. To record this activity, attributes can be added and associated with the WBS ID, the activity label or name. As part of this process, we can also identify milestones. The pouring of the coffee is a milestone. Perhaps the completion of the grinding is a milestone, as could be the completion of the brewing. Each subsequent activity cannot carry on until the previous is complete. With all these elements in mind, we now have produced updates for our project management plan. We've established a schedule baseline where work packages from our WBS are now given greater detail as activities. A schedule baseline is defined by the PMBOK as the approved version of a schedule model that can be changed using formal change control procedures and is used as the basis for comparison to actual results. While we won't talk about cost until the next episode, we've also created our cost baseline by defining the activities and work involved. We can quantify those with dollar values in cost. Cost baseline is defined by the PMBOK as the approved version of the time-phased project budget, excluding any management reserves, which can be changed only through formal change control procedures and is used as a basis for comparison to the actual results. Now that we have the activity list, we have to put them in order by sequencing them. Sequencing activities is defined by the PMBOK as the processes of identifying and documenting relationships among the project activities. To do this, we'll need some of our usual suspects or inputs. We'll need our schedule management plan, our scope baseline, which we are already familiar with, the activity attributes, the activity list, the assumption log, and milestone list, all items we just completed, and our best friends forever, Fs and OPAs. With our references in hand, I know, we need to create a picture using a precedence diagramming method, or PDM. Basically a bunch of boxes with arrows coming out of them. The first kind of arrow we'll see is finish to start. When the first activity is finished, the next activity can start. Easy, right? You can't brew coffee before you put the grounds in. Well, I suppose you could, but where would be the caffeine? The second kind of arrow is finish to finish, where the second activity can't complete until the first has finished. If my coffee is part of a healthy breakfast and the food was on the table, breakfast wouldn't be served until the coffee was served as well. Once the coffee, the first item to start but the last to be served on the table, is on the table with the rest of breakfast, then breakfast is served. The third type of arrow is start to start. Here, the second activity can't begin until the first activity starts. I can't start to listen to my car radio until I turn the car on. I can't start my shower until I turn the water on. I can't watch the Maple Leafs lose another playoff run until the playoffs start. No, you're right. That's a bad example. They'd have to make the playoffs first. The fourth and final arrow is start to finish. This is where the second activity can't complete until the first activity has started. Going back to breakfast, I know I can cook eggs in the time that it takes to brew coffee. So I start the coffee first so I can start and finish making eggs before the coffee is ready to be poured. Now there is much more to these PDMs and network diagrams, which is beyond the scope of this series, but in future courses we will explore this in greater depth. Let's take a moment to take stock of where we are. We've planned how we are managing the process of creating a schedule. We have defined and sequenced our activities, but now we have to get into the nuts and bolts of scheduling. We have to talk about time. Estimate activity duration is the process of estimating the number of work periods needed to complete an individual activity with estimated resources. In order to do this effectively, we need to consider scope, resource types or skills required, and quantities of resources. Our inputs will help us with this. We will need our schedule management plan, our scope baseline, activity and attributes, milestone lists, our assumptions log, lessons learned register, and a couple of things we don't have yet. So we'll have to revisit the schedule after. These extras are the project team assignments, resource breakdown structure, resource calendar, resource requirements, and risk register. We will cover these in later episodes on resource and risk, so not to worry. As with stakeholders, we will need to revisit the schedule before we leave this process group. Oh, and of course, our Fs and OPAs. As before, with these references in hand, you'll need to turn to some of your expert judgment. These would be those with experience in scheduling, estimating, or specific projects or applications. When estimating, there are a few ways to approach the problem. Analogous estimating is comparing this project to similar ones or using historical data to create a guide. This method is usually quick and costs less than other techniques. Parametric estimating is using a formula to calculate costs based on historical data. Charging per square foot, for example, in construction is an example of this. Bottom-up estimating is a method of breaking down the cost of the individual components or lower levels of a WBS. By estimating the duration of the component work, the whole project can be estimated with a reasonable level of confidence. Three-point estimating is a combination method of estimating that incorporates risk by combining three different values: an optimistic or best case with a pessimistic or worst case and a most likely scenario. A three-point average can be reached when dividing their total by 3. A more sophisticated version of this is a PERT or program evaluation review technique. In this model, you still add the optimistic and pessimistic together, but you multiply the most likely scenario by 4. With a total of 6 data points now, 1 for optimistic and pessimistic, and 4 for the most likely, you then divide by 6 to get the accurate average. Good news, we're in the home stretch, so now all we have to do is put it together. We take everything we've created and used up to now, including our best friends, say it with me now, Fs and OPAs. We take all those references and we perform a scheduled network analysis. That is where we create a node diagram, the boxes with the arrows, and map out what needs to happen when. So please refer to your handout for reference on how these are laid out. Critical path methodology uses this diagram to estimate the minimum project duration and the amount of flexibility in the schedule model. Exploring critical path in depth is beyond the scope of this course, but will be covered in future offerings. A critical path model can help optimize resources throughout the schedule by resource leveling or resource smoothing. Resource leveling is a technique of averaging out resource use over the life of the project. Resource smoothing is setting a cap or peak use of any one resource. One difference between these two is that resource leveling can affect the critical path of the project, whereas resource smoothing does not delay the completion date. Once the timeline is fully laid out and appreciated, this can be represented in bar charts or Gantt charts. Usually mirroring a WBS format, activities are listed vertically, up and down, and time laterally, left and right. Milestone charts can be a simplified representation indicating activities, again, vertically, up and down, and their corresponding milestone date laterally, left to right. A network diagram can be activities in various nodal boxes connected by the various arrows we mentioned earlier, or those same arrows can appear on the Gantt charts illustrating the relationship with other activities and milestones. Wow, that was a lot. But now we have our project schedule, and just like in our last episode, we now have a schedule baseline. In today's episode, we defined planning schedule management, defining activities, schedule baseline, cost baseline, sequence activities, estimate activity durations, analogous, parametric, and bottom-up estimating, 3-point and PERT estimating, and we introduced critical path methodology and tools such as Gantt charts, milestone charts, and network diagrams. In our next episode, we'll be discussing cost and determining our budget. Is now 1 cup of coffee. 1 cup of coffee. 1 cup of coffee. Ooh, 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 ooh.